All right, this is AP Chem topic 2.4, structure of metals and alloys. So the metallic bond is a little bit unique. It is made up of what we call a free-flowing sea of electrons. So the metal atoms lose some of their electrons, and the number of electrons they lose varies. But the cation, the nucleus and the electrons that stay associated with it are fixed in place. And then the electrons that delocalize move freely between them. And so in this way, these atoms are sharing electrons like we've talked about before with a covalent bond, but it's very different, okay, because they can move about freely. And so they're not bound between two specific atoms. This gives metals some of their unique characteristics, including the fact that they are conductive, that they're malleable and ductile, meaning you can pound them into sheets and that you can pull them into wires. And generally, they're pretty soft. Now, the other features of metals vary widely. You can have metals that have very low melting points, and you can have metals that have very high melting points. But let's talk about this fact that they are soft for a minute, because a lot of times we want to control that, along with other properties, but we're going to focus on the softness for a minute. So if you want to change the properties of a metal, the best way to do that is by forming an alloy. And there are two types of alloys that we're going to talk about. The first one is interstitial. So an interstitial alloy is where you have, or any alloys where you have a blend of two metals, okay? So an interstitial alloy is where you have a larger metal atom and then a smaller atom that slots in the open spaces between the metal itself. So this could be a smaller metal or it could be a nonmetal. A great example is steel, which is made of the metal iron, and then carbon slots in between. Because the smaller atom slots itself in these open spaces here, it makes this blend much harder than the metal on its own. It changes some of the other properties too, but again, we're going to focus on the hardness for the moment. The second type of alloy that we are going to talk about is substitutional. Substitutional alloys happen when the atoms are of more of a similar size. And so it looks like this, where you might previously have had the same kind of metal here, you would substitute a different kind. So an example of this is brass, and that would be a blend of copper and zinc. So again, this would change the properties of pure copper to something that's more desirable for whatever your application is. So sometimes we do alloys because they might be more resistant to corrosion, or they might be cheaper, or they might give some other like heat property that we want. So there's different things that they use alloys for. Now, one thing I want to point out here, this is not like a lattice. You notice that there's not a repeating pattern here. This is a blend, and the blend is predictable. You would look at it as percentages, but which atom specifically substitute for which other atom, that is a little more random. But I'm going to come back here to end, because the big thing to remember with metallic bonding is this free-flowing sea of electrons, and that's what you're going to use anytime I ask you to justify anything about a metallic bond. You want to think about it in terms of this. And when you're thinking about alloys, you want to think about the size of the atoms. So is it going to be interstitial or substitutional?